All right, so hope you have a great break, and next 30 minutes I will at least try to give you a Swiss type demonstration. Just small information. Emil, we had a great adventure in Japan in July where we had the opportunity to be at the headquarters. We give a great demo, and Emil, just after this demonstration, he called Natalie and, okay, you need to put this demonstration also to do the same thing over here. I said, I can't repeat the same demo, twice. I think that for all you salespeople know that you cannot perform 2 demos twice. Yeah, so, but at least I will try. That's for sure. You probably remember my presentation from yesterday. 10 key facts and features that why I think SolidCAM is the #1 CAM for Swiss type solution and for multi-channel machines. And all of these stuff are very important. And I'm trying every time when I'm showing something on a demo to touch every of these key points. Now, for the Swiss type, what is very important, I figured that out going to the customer sites and helping also resellers, that you can only impress the customer if you're talking Swiss language. So if you're talking machining language and you impress this operator, this technical manager, then you have a great chance to win this deal. This is the only way. Now, what is the best way to impress them? The only way is that you know exactly, and try at least, to get the information what kind of machine he have on his shop floor, what kind of parts he's machining, what kind of tools he's using. Because with that, you can ask him what kind of problems you have with programming your parts now. So you can focus your demonstration on the problems that he have daily. So this is the most important. Of course, you cannot get all the time, can you send me your part so I can see it, or maybe can you also get, can I get G-code example from the machine that works? This is also good information, as you can prepare and output it accordingly to his needs. This is also what buys them. But there are many cases when they will not share those, right? So I'm going to show you the demonstration within the next 25 minutes. I will try to touch every of these points, showing you lively how to present it on the software. I know that there are many sales. I'm personally not the sales guy, right? But I will try to show you how I'm doing it in SolidCAM. For this, I have prepared one demonstration pod, which more or less has all the geometries that you can do standardly on the Swiss. And there is some geometries for the drilling, tapping, face, radial interpolations. There are engraving here, as you can see. You can use eye machining as well. Drilling, you can use 4 axes simultaneously. Very important to demonstrate it. There are always customers saying that we can do standard stuff. That's okay for me. But we always have some kind of part where I need to use advanced picking on the geometry, and this is where I handle it at most. So I'm going to open the SolidCAM, and I'm doing it the standard way. Do you want to save it? It's not saved. Okay. I hope that's okay. Okay. So pretty standard. I'm just going to make a demo solid, and we just click OK. Standard, nothing so special. The very first step, you all know, I always mention, whenever you have a SolidCAM and all your machines on the floor, the very first step, what you need to do is to select your proper CNC machine. Here is the list of all your machines that you will have on your floor. I'm going to pick the one of them. In this example, I'm going to use the Citizen machine, the one that there is also in the Citizen, in the Schramberg, in the Technology Center, the one with the ATC. So it has the spindle with automatic tool change and together with the B-axis. You've probably seen on many of these videos shown here. And what is very important, I will pick and select the coordinate system, and it will be there just for programming the way how I like it, that my x-axis goes towards some geometry. It's not really necessary to do this. I'm just going to show that any kind of manipulation with the coordinate system is important. Many of the elements here that I'm going to show, I will show it shortly, right, because of the short time. But it is important that you show that any coordinate system manipulation is possible. Now, what you see in the next moment, everything is automatic. So customers like to see that something is happening in the background, but while this is happening, try to explain them what is happening. So coordinate system is automatically created, stock is created for you, envelope is automatically created. And you can see it over here at the left that everything is done already. Per your settings, you don't need to do anything. He always worried, but I want to change something. No worries, if you want to do something manually, you can always change that inside the settings. Hey, what you have here, I have the program number. So your program number, whatever you type here, will be the PRG. And this is a small moment where, when you know that this is Citizen, you know that the output will be PRG, and then you connect it. This is small detail, but he immediately speaks with someone who understands also the machine. So now you are getting connection with some who is there technical as well. Now, we have here also some machine options. I will not bother you with them, but it's good to show. Wow, this is important. Okay, yeah, so you explain him. So you need to also have a technical guy who knows the machine also well. All right, so I'll just click OK, and that's all thing what you need to do. During this, I'm saying, look, this is usually the process of just 10 seconds, and that's it. You don't need to do that all the time. The next step, I like to open my toolkit. Inside the toolkit, I show the machine. Hey, machine preview is something that none of the CAM has. This is your true kinematic of the machine, and in any step of your programming, either you are in the toolkit, either you are in the job, setup, MCO, you have a possibility to open machine preview. It gives you kinematic position of your machine and allows you to define anything you want in the machine environment. And then he say, okay, you see, there's no tools here. So what is important, and I mentioned in yesterday's presentation, why our toolkit is the best in the world, is because he has so easy way to manipulate with the tools, fast change any tool layout. This is extremely important in the Swiss. And what I'm going to do, I'll just load it. I have predefined this, and with simple click, mount all tools. Maybe you can all see it over here. I will unzoom it. Please pay attention in the machine preview. This is already, they say, wow. They're already impressed here, but don't stop it here. There are so many features that you can show that can be used. For instance, you can say, yo, you see these 3 tools over here? 2 tools, but 3 stations. If you're willing to exchange them, no problem. You don't really have to click on the tool itself. You can click on the holder. You have this option, select tool components, which is going to highlight the specific component in your library. And of course, to select whole component of whole assembly. So you want to put it on the tool number 7, just drag and drop, and now it's on the tool number 7. Okay, that's fine. But look, what I want to do also, I can just copy, I can do paste. It's so simple. But what if I want to exchange number 8 with number 9? No problem, just go 8, you have it here. I want to exchange it with number 9, switch it. And where it is? Ah, here. Done. So this is what customers like it, that easily you can switch your tools. You can do that also for any of those over here. I can just select it, just move it to the 34, no problem, there you go. So easy switching layout, so customers don't like to waste the time with switching the layout. What you can also show, I want to change the diameter of those tools. So this is not what actually I like to see here. You can show him that this is everything, it's live. So everything what you do, it is presented lively in the preview. Okay, so this is the tool layout that we are going to use in this demonstration. All right, so that's it. So the next step is the setup. Inside the setup, we are talking about the machining length. So here's your pod, going to the maximum machining stroke. and I can tell him, hey, what will be your Z limit for your per stroke? Here it is. You can dynamically see it. But not only that, you can also see where you are going to clamp your part on the subspindle, for which I'm going to use the Mach 2, and dynamically just place the value, and here will be my catch-up position. This will be extremely important when I define my MCOs. You will see that later on. And 7 exit. So at this point, I stop because I try to explain him, although these steps can be done more or less automatically. With simple clicks in 10 seconds, you already start doing your operations. But for demonstration purposes, I'm trying to tell him, look, this is what we have. These are the steps in the case you want to do something, change also manually. As there are so many geometries here, it will be completely unrealistic that I define all of them. I could use automatic features as well, but I will just go and define some of these geometries, not all of them, but to emphasize also on our integration and our associativity. So I go, of course, through the interface as well, showing that on the top you can find all the SolidCAM operations, starting from the 2.5D, automatic feature, 3D, multi-axis, also turning, and I start with simple phase. Every of our operation in SolidCAM is within this single window. No matter what job it is, it looks pretty much the same. Only what is changed are the parameters of each of these segments over here. So let me just define simple facing. I'm just going to accept it. I'll just make sure that my geometry goes all the way to the bottom with auto extension to the end stock, and I'll click OK. You may also change the operation name, and now it's the time to pick up my tool. Well, I didn't show this also. I am showing this also. I showed this also yesterday. You can pick any tool, not going through your tool page and just select it, which will bring you to a toolkit. That's fine. But it is so much convenient. You know, the Swiss-type machines can have 30 tools, 40 tools. So you have a huge list of where is this tool, finding it in the list, it's not convenient. Use the advantage of machine preview. So you can just easily just go right-click, select tool component. He is going to pick the tool and show it here on the left side. It's done, and that's it. Let's go further. What I also like to emphasize are our parameters and the picture, how intuitive our software is. So by just going to any of our parameters, I don't need even to click it. You just move your mouse over it, and you see at the bottom here the parameter the picture that describes this particular parameter. SolidCAM has at least 5,000 images which describes each particular parameter. That's intuitive. Also, yesterday we've seen that we also start to support the movable pictures, GIF files, right? So we will also work on that as well. I go to the technology, I can go to any of these parameters and convince customer, look, anytime when I move this, it's changed, right? What you can do also, it's easy to learn. I mean, yes, it is intuitive, but if you want to find something more, there is offline documentation for you that you can do. So over here on the top, you will find this question mark. You can always click on this and move to a particular parameter. What, I don't have the internet? Let me try again. No? Let me try again. Apologize for this. It should probably, because there's internet. It should guide you to, let me try again. Maybe, okay, sorry. It didn't work with that parameter. But if you go with question mark to specific parameter, we will drop you to the specific section where you can find more information about specific parameter as so. All right. Everything is defined. I will just go this with the finishing. I will just save and calculate. What is interestingly happening at the moment is that, hey, look at this. You can dynamically see your toolpath. That's fine. But you can also see where this particular tool and part is at this moment kinematically in machine environment. Also, again, and emphasize about machine preview feature. Right. Let me define a few more operations. I'm going to go outside diameter turning. I'll do this a little bit quicker this time, but I will define it with a solid. I will click on this geometry. I will click, for instance, for one of the last. Maybe I don't see it here. Let me try it again. So over here, I'll click on this. There you go. So all this chain is selected. Don't worry, I'm not going to machine all of this. But I have a possibility to modify any particular geometry. This is extremely important if you have the guide bush. Now, the guide bush moment is important as every collet can be different size, of course. So you cannot really machine complete part within let's say one operation, okay? But for this demonstration, I just mentioned this, but I'm going to, of course, clean whole part. But what is important to show that you can just go over here and you can trim your toolpath to any point. Look, just by clicking, and he trimmed your toolpath. I can just go over here and click over there. That's good. Now I can go and also auto-extend my stock within the angle. I can say here, -10, which is very nicely to finish some geometry. I'll just click OK. I can also mention here it's OD turn. I can go to same of my tool. I will just reselect it. Here it is. What is interesting also to see here, you see that my next job is not even calculated. But what I can see at the moment is that where my operation was before I selected. So I will just this time go to the technology. I will do it with rough, make corrections. This will be all fine. I will not change too much of the things. I will do it with the finishing. I will go to the link. I will do approach with the arc and hit save and calculate. It's so easy. It's so nice, right? But what we can do more? For instance, we have a very nice option here in the technology. If you go to the general, for the guide bush purposes, there are sometimes a situation when you really need to go more than allowed by the collet. So in such a cases, you need to break the corner material on the stock. And that's so good that we have this option. I really like it. So you can put any parameter here, and it will really cut. It's like so. I will simulate it. I'll go to turning, make a simulation. I will just run it fast. Here it is. I have this break over here. All right, so what I can do also, I can just say non-descending mode, no problem, 7 calculate. It is so fast. It will not go here to those things, right? I will go to the geometry, modify geometry. I want to now cut all this geometry, just click OK. Because of the time that we have, I'm just going to machine all this stuff here. OK, in addition to this, I'm going to make a growing operation. I'm just going to turn off this job. And I'm going to select from here to here. This is my first chain. This is my second chain. And my third chain. Perfect. Again, I will go to my tool. I will select, but this time different tool. I have the tool over here. What I didn't mention here is that all of these shanks, you see that they are 3D model imported one, okay? Good also to show during the demonstration. I'm going to select it. I'll go to the technology. I'll do the rough, step over, semi. I will just go advanced down, and maybe only X in 22 and approach it like so. 7 calculate. There you go. Finished. Okay, so where we go further, now you start to say, look, but we have so many milling operations. Let me show you. I always like to start with the one from the face. And I will go to our 2.5D. And I'm going to use our pocket. All right. I will click on the chain. I want to define this with a chain. And what you need to do, just simply click on the surface. He's going to find all of these. I don't need to do anything special. So try to show how easy it is to do this. But this time I'm going to do this with the B-axis. My B-axis, here I'm going to find a tool. It's here on the top. 4 diameter end mill, like so. I'm going to open my preview. Here it is. I will go to my levels. What you can see here, I have my upper level and I have my pocket depth. Both of these sections are green. Make sure you emphasize on your demonstration. Hey, why this is green? Can you guess? And he'll say, oh, you define everything correctly. No, 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 no. It means when I click on these particular surfaces that you are associative with this geometry. As he said, what is associative? You will see very soon. So I'm going to 7 calculate. I think nothing. Oh, yeah, I'm going to just define the finishing and just wall finish only. Maybe some link, arcs approach, same as the lead-in. 7 calculate, and the B-axis on the spindle is used. Showing the toolpath. The toolpath is here. All is good. And now, what I usually like to show is, okay, I have one from the face. Good. Hey, do you have a face interpolation cycle? And he said, what do you mean? Do you have a cycle in your machine 12.1? Oh, yeah, I have it. You want to run it on this machine? Yeah, but I never tried with a B-axis. Yeah, we can do it. We verified that also. The post-processor supported very well. Oh, I would like to try it. So you go to the motion control. Just turn on the forward axis here. Just click it, and you can already see that it repositioned. I can 7 calculate and say, can I see a G-code? No problem. I'm just going to generate a G-code. Click OK. And your 12.1 cycle will be there. He say, wow, this is amazing. Okay. You don't want that? No problem. But you have also the option to control any of your C-axis position. Here at the bottom, this job is currently on the C0. If you want to do any other angle, just put the value and it will be there. At the bottom, you can see now the C-axis gets updated. But that's not all. Now it's the time when you create the first milling job, now it's the time to show drag and drop. So, I want to show you something. This is something you've never seen before. So we define this job over here, but I would like to define this job on this surface. I don't need to create any coordinate system. It is done. What you can eventually do, maybe you don't want to do it with your B-axis. Maybe that's also okay. I will disable the preview. But for instance, I would like to take with this tool. No problem. I'm going to do it with this one. Save and calculate. There you go. Now I'm using this tool for this specific job. Okay. What's next? 2 jobs, it's okay. Let's move forward. My next job will be 4-axis simultaneous. Now, this is a very simple geometry here, indeed. But there are a couple of things that I like to mention when you're showing the 4-axis. Oh, every customer knows how the 4-axis toolpath looks like. That's sure, but mention some couple of technical things here. I'm going to do more between 2 boundary curves. I'll click on geometry. It's clear that my geometry will be this surface. I'm going to multiply everything when I will just select this. Pardon, I also didn't turn off these stuff here. I'm going to select this edge. Let me make sure that I will reselect my surfaces as I didn't select the Mac, so I will do it again, make sure I turn off these, click on the edge, accept it, accept it. Click on the edge, accept it, accept it. Okay. Oh, I say accept it and I didn't do it. Okay. I go to my tool. I'm going to select my bull nose mill in this case with the B-axis. Is it this one? Yep, exactly this one. I'll go to accept it. I will change mine to the cylinder, going with a radius of 10 or maybe 12 I can do. 2 here, 0.25 cut tolerance. Just for the calculation time, I'm just going to reduce it. Rotary, point here, and just 7 calculate. Let's see what is the toolpath. Pretty good, not so bad. Of course, what I'm doing at the moment now, calculate the toolpath, add some lead in. So how difficult it is? No problem, just use the lead in. Here is, I don't want to use a default, go to vertical. Look, save, 7 calculate, it is there. You can, of course, I have these retracts. I would like to get rid of it. No problem. Let's go here. I would like to do a one-way. I will go with, let's say, this is okay. I will just say 7 calculate. I want to do it one way. This will be fine. And if you're satisfied, I go with the roughing. And I want to do a depth of cut, 2 here, 0.5. 7 calculate, and show him this toolpath. That's it. Okay, I want to also rotate and translate, no problem. I'll do it 5 times. My rotation angle is 72. 7 calculate, done. Okay, so what is this technical stuff that you want to mention? You know, usually Swiss-type machines, they come with a very small memory. Just generating this G-code will take about 20,000 lines in the code. Very often, customers are buying a machine that doesn't have a huge memory. So what is important to show that, hey, look, there is something here that we can output as a sub-program. And this is very important to mention. No problem, 7 calculate, generate the G-code. And what the user, what you're doing here that, hey, maybe he never run any huge G-code, and now this is, for the first time, he's going to see like thousands of lines. Obviously, this is the 4th axis, but he never run it from the CAD, right? So I have the main program. You show him the main program. Here I'm calling the sub-program, and here's the sub-program. So those are small technical stuff that buys also a customer opinion, okay? Right. Do we have something more? Yeah, there are more jobs that I can add here, of course. But let me go towards the MCOs. In this process, I would like to make a cut-off operation. Of course, Swiss-type machines are very complex. You need to turn on the spindle synchronization in the time when he clamped the part. You need to turn on the axis synchronization. It will go into superimposition mode. A lot of things. This is something the customer consider like, okay, I want to do it very, very fast to define it. I don't want to lose the time with it. You can show him that he can create a process template. I'm inserting all of this stuff with a process template. I prepared already, and I have the pickoff cycle. All of these operations are there. I'm just going to click OK. I have one cutoff operation for which for this I will not define. I'll just click OK, and all these MCOs will be there for us. And say, whoa, here it is. That's all. I will go through these MCOs a little bit to show you what they are. But for this, I have one cutoff operation for which I'm going to define a job. I want to do it like so. I will just modify my geometry, make sure that it goes all the way down. click OK, select proper tool. On most of the Swiss type machines, the tool is number 1, on most of them. And the offset is 0.27 calculate. All right, here it is. Here is the job. So what are those operations here? Let me show you a couple of them. So I will go to the Z1 positioning for the pickoff, and what we always offer, this is our MCO operation. We always give a user all predefined MCOs for specific machine. This one is Z1 prepositioning, and what is again good, you have again your machine preview. What you can do, what we always offer, this is our last position of my previous tool, and what I would like to have is my preposition on the X, which is 22 in diameter, and I have a Z1 position of 50.2. So my part is 50, so I go with 0.2 as well. So I'm just going to click. There you go. This is my predefined cutoff position, and that's it. Okay, so what is also interesting? Z2 positioning. Look at this. It's my pickoff cycle. My part is ready. Everything is okay. I have here position, pickoff position, 5 millimeters exactly. Oh, I'm pretty sure that this will not hurt anyone, so I can go 2. Oh, I have my end position, which is my setup location. I said, what this means setup location? I go and click and I show him, do you remember my setup when I show you that this was like 10 and then, oh, this picks automatically? Yes, absolutely. So you go to your setup, you remember this parameter, okay? So you want something else? No problem. I'm just going to zoom to the part. You can also use this icon, by the way. It's very handful. So you can just click. For the sub spindle, it's here. And I'm going to change the position, obviously to a different clamping position. I will go to my prepositioning, parameters, and hey, look, it automatically changed. You don't need to do, you do nothing here. Everything is done for you. So automation. I click, new clamping position. And for the end, there are a couple of jobs that I like to do on sub spindle, of course, everything it's fine, but I like to show here the part eject. Also, we have the part eject, something that Swiss type users like to see. My part is successfully transferred, and I have my eject position, which is over here. I can change it to any value that I want, and it will properly change the G code. So this is more or less everything that I showed during the, to feel the user that, look, this is fast programming, very intuitive, easy to use. I will, because I changed the setup, I will just recalculate those jobs over here. And what I have is sequence, operation sequence manager, something that you need to show. So this is how it looks like. Hey, you know what it is? On the left side, it's everything what you do on your main spindle. This is your channel 1. Anything what you see on the right side is your channel 2. Everything what you do on your sub spindle. We have the axis patterns. You see these black lines? This is how your machine communicates within the first channel and second channel. You call these weight marks, weight codes, how you call them. So this is the way how to communicate with the customer. So you want also to see 2 parts? No problem. Right-click, add a new workpiece. I'm going to delete this weight mark. I want to happen simultaneously while I'm working on the main spindle. And what you have here is right-click, also axis patterns. They are automatically defined. In the case when you have more options, you can also change them to the proper. As for the citizen, this would be the proper one. And as there are no clashes, I am able to simulate it. I'm able to generate the G code. Good. Also, in the channel synchronization, small thing I didn't show. At the bottom, you have the total machining time. Show them before synchronization, show them after synchronization. This is very, very good and important. Okay. Two things. I'm going to show you this. Associativity, guys. I'm going to close my part. I open this. I will change a couple of things, not more. I'll just show the customer that, hey, look, this is something that you can do, just like so. It's done. So obviously we have a different geometry here. It's on a different level. Over here I have, what it is? I think it's this. Is the cut that I'm going to change. It's not 2 mm. Let me put 1.5. I want also to change my envelope. Let me put here something small so we can obviously see the difference. This will be shorter. Let me put this on 5. Yeah, this will be enough. Okay, so different part, obviously, right? So I'm going to save it. I close this part. I explain the customer what is happening in the CAD design department, also CAM design department. Those departments can be completely separated. Emphasize on this. If he changes it, hey, you're going to, it's all right. You open your CAM part, and this is the pop-up message that appears. They're showing what this means. You change your model. Do you want to use the old one or the new one? Oh, great. You click yes, change it. All those things that you see, those are jobs that require recalculation, synchronization. Obviously, here we have a 3D model that doesn't follow the previous envelope. Everything is different. So what I'm going to do, right-click, synchronize. Behind the synchronization, you all know here, we are going to rebuild our envelope, replace the geometry, and every single parameter which was associative to a model is going to be recalculated. The last step is recalculation. Of course, we are giving the user to do this completely automatically, that he don't need to do it, but I like to see the process. You can see it, everything is there. So, I hope you like it, so please. And the last step is the G-code generation. I also like to talk about that, but I will skip in this demonstration. And Emily, you want to say something? Or? Yes. So absolutely important. All right. And thank you guys for your attention. Look, I have one bonus thing to show as I didn't show yesterday. It will really take me 2 minutes only. I was thinking yesterday when I was showing you the fixtures, and you remember this part. And just to remind you about it, we have this collet, right? And I was thinking like, okay, I defined this one. Let me just remind you for a moment. So we define here the fixture position. We also define here the part mounting position. Again, something about associativity. This fixture is associative with the one that you've seen in the CAD. So let me show you this. I will just close this. I will open my preview. This is my setup location. This is my fixture at the moment. I can see my part mounting, it's over here. Okay, that's all good. But let me show you this. I open my part, my fixture. I'm going to change it. I have also equation. You can do this also manually. I'm going obviously to change this. I'm going to update. You will all agree that this is different fixture. I'm going to close it. I have different fixture in my environment. Still, nothing changed in the background. So everything is inside the toolkit. Everything is there. So still my previous fixture is there. But you can do a right click inside the setup. and check synchronization and synchronize. This is one way to do. Another way to do is just right-click here, and you have new two options. Check synchronization, which is obviously going to mark that something has to be changed, and you can now synchronize it. Behind the scenes, we are repicking the stuff, paying attention where my part mounting is, and everything is updated for you. Thank you for your attention.
By the way, when I told the SO people that SolidCAM had no associativity, and I sent them even documents to prove that, they invited us, a whole team of SolidCAM, and got their best demonstrator, and he tried to show us what they mean by associativity. It was a complete failure. This is real associativity. So, by the way, you know he's not using regular SolidCAM. There is a version called Super SolidCAM. Only if you do all your certifications, you get access to it. Really, how are you going to get all our demonstrators to do that, what you did now? Give us a plan.
Yeah, I need to create a plan, obviously. But it's not so hard. I believe I didn't show any part magic. It's just like...
No, but you have to plan, train.
Yeah, to plan and train, okay.
Okay?
Let's see about that. Yes.
Okay.
Sure.
Anyway, we'll put another level in certification. It's what's called, Linda, wait, expert certification. And he has to sign on it. Anyway, just I want to tell you something about, you saw this demonstration. When the people of Citizen, who have been working with Esprit all their life, saw it, I told you, they said, unfortunately, we are working with Esprit. Because I tell you what's the story of Esprit. Esprit was the king of Milton for many years. Then the owners of Esprit made a huge mistake. They had to upgrade Esprit, but they said, no, we'll write a completely new program called Esprit TNG, they called it, 10 years ago. And they decided not only to develop a new CAM system, they decided to develop also a new CAD system, instead of thinking, why don't we integrate? So for 8 years, they were trying to develop this Esprit TNG, and it didn't finish. Full of bugs, problematic. Meanwhile, what's happening with regular Esprit, they call it now Esprit Classic. No changes in it for nearly 8 years. So they are stuck with Esprit Classic, cannot be updated. Esprit TNG doesn't work. So what did they do? 2 years ago, they suddenly published an article, Artificial Intelligence in Esprit. Put 2 articles, somebody in Hexagon, doesn't know anything about CAM, believed it, and they bought Esprit. And now they are stuck with Esprit, no artificial intelligence. Since they bought it, nobody talks about artificial intelligence, although they said they bought it because it's the only CAM system that has artificial intelligence. By the way, something more I want to tell you. I just heard it from one of our new staff in the United States who worked in Hexagon. He just joined us from Hexagon. And he was selling many CAM systems. You know, Hexagon bought about 10 CAM systems, and they are now selling about 5 of them anyway. He said to me, I couldn't believe it, but that's what he said. Hexagon is going to give coupons to machinists. And with these coupons, they could go to their website and choose any of the CAM programs, every day another one, and work with it. Can you believe these people know what is CAM? So,
Supermarket.
I want to tell you something else about our other friend, enemy, MasterCAM. I mean, these are our 2 competitors, really, Esprit and MasterCAM. Now we know the story of Esprit, let me tell you the story of MasterCAM, where they failed. You see, they were the king of CAM, and then they decided, okay, SolidCAM integrated, we'll integrate also in SolidWorks. I was in an exhibition, IMTS, in the United States. Somebody introduced me to the CEO of MasterCAM. I asked him, how are you going to do the integration with SolidWorks? Are you going to take your CAM as one module, make a bridge? I was giving him a hint, a big hint. That was a mistake. Make a bridge to your own CAD and make a bridge to SolidWorks. That's the only way to do it. He said, no, I'm taking 2 programmers on the side and they'll do the integration. At that moment, I realized it will fail because you have the main MasterCAM and you have the bastard small Mastercam for SolidWorks, and it never worked. They tried it nearly for 10 years. They go to a demonstration, they show the Mastercam for SolidWorks, but then when the customer buys, they give him the real version that works, Mastercam. If they would have succeeded in making integration with SolidWorks, we would not be here today. I could tell you the reality. And then they made another second major mistake. There was a company in Switzerland called Sylvie Expert that developed specific software only for Swiss machines. Because they are sitting in Switzerland, they developed software for a Swiss machine. They couldn't sell it. Didn't know how to sell, so they came to visit us in Israel. They said, we want to sell you Sylvie Expert. Okay, they demonstrated, it looks nice. So we had a customer just 100 meters from our office. I said, okay, he has a Swiss machine. Install it with him, let us test it. So they said, which machine he has? I told them, this machine. They said, we don't support this machine. I said, okay, so write a post for it. No, he said, everything is built in. It will take us 3 months to support this extra Swiss machine. I said, bye-bye. Do you know who bought them? Mastercam. They bought them. They called the product Mastercam Swiss Expert. For 7 years, they struggled and struggled and struggled. Finally, they killed it. Meanwhile, the Mastercam itself was never developed, the product itself. So finally, they also sold to Sandvik. So our enemies, friends, make mistakes, and we benefit from them. By the way, this is a broadcast live, so now all our enemies are hearing the truth.